Hi everyone, my name is Raden Fatih bin Mustati, and I am presenting my final year project for Pixel 2026 under the supervision of Dr. Azman Abdul Malik. So my project is titled Facial Recognition with GPU Optimization for Secure Medicine Mixing Machine, a system we call the dilution. So I will walk you through the motivation behind this project, the problems we identified, our proposed solution, and how we design and build the system. So, for the introduction, the dilution is an intelligent automated medicine preparation system. At its core, it aims to do two things. First, automate the medicine preparation procedure to reduce the reliance on manual repetitive processes. And secondly, reduce human error caused by fatigue or carelessness in a high stakes medical environment. So, my task is to build a facial based security system to ensure that only authorized personnel can operate the machine. The hardware stack includes an Intel RealSense D455 depth camera, a web dashboard for administration, and the NVIDIA Jetson Ordinano as the edge computing brain of the system. More specifically, the dilution machine used a contactless biometric access control system designed to secure a medicine mixing machine. The system used the Intel RealSense depth camera to perform 3D volumetric leafness detection, which means it can tell the difference between a real human face and a flat photo or video, stopping spoofing attacks before they happen. For recognition, we built a custom convolutional neural network architecture that also enforces mass compliance, ensuring that operators wear proper protective gear before the machine activates. All of this runs locally on the NVIDIA Jetson Ordinano with GPU acceleration via NVIDIA TensorRT and CUDA, enabling real-time performance without any cloud dependency. Finally, the whole system is managed through a React.js web-based administrative dashboard that provide live telemetry and secure data management for administrator. So the key motivation is very simple. The most healthcare machine system today lack effective anti-spoofing measures. This means unauthorized individual, whether through stolen credential or impersonation, can potentially gain access to critical medical equipment. When we are talking about medicine mix machine, unauthorized access isn't just a security issue; it's a patient safety issue. We need a solution that was robust and intelligent. So for the problem statement, the first problem we identified is the vulnerability of traditional access methods. Systems that rely on access cards or pins are inherently prone to impersonation, theft, and human error. These methods fundamentally compromise safety in medical processes. A stolen ID card or a shared pin is all it takes to bypass the traditional controls. And in a medicine preparation environment, that's simply not acceptable. The second problem is inconsistent user enrollment. When there's no standardized interface for capturing facial data, image quality becomes unpredictable. It becomes blurry, poorly lit, or inconsistently framed photos, which directly reduce recognition accuracy. If the enrolled data is poor, even the best AI model will struggle to correctly identify users. Garbage in, garbage out. The third problem is the fragmented system integration. When hardware and software are not unified under a single backend, data synchronization breaks down and you lose the ability to maintain a reliable audit trail. In healthcare, accountability is critical. You need to know who exactly accessed the machine and when. A disconnected system simply cannot guarantee that. Based on these three problems, we define three clear system objectives. Objective 1, develop a GPU accelerated facial recognition module using a custom CNN optimized with NVIDIA TensorRT and CUDA on the Jetson Ordinano for real-time identity verification in the medicine mixing machine. Second objective, to integrate the Jetson facial recognition pipeline with a Node.js backend and SQLite database, enabling seamless, reliable, and communication between the iModule and the IoT hardware. And third objective, to build a secure authorization and data management interface using React, specifically for user registration and guided face capture, solving the ecosystem enrollment problem directly. Now, let me walk you through the proposed solution. The first pillar of our solution is the HAI authentication unit. This is the facial recognition engine that runs entirely on the NVIDIA Jetson Ordinano. Locally, it uses our custom CNN model optimized through NVIDIA TensorRT and CUDA for extremely fast inference. This means authorization decision happens in milliseconds right at the edge. So the second pillar is our anti-spoofing security layer. The Intel Ryzen D455 fetch both RGB and infrared depth data simultaneously. Our system performs 3D structural analysis, comparing the depth map of the face to distinguish a real three-dimensional human face from a flat surface like a printed photo or a phone screen. This means the system automatically blocks photo and video spoofing attempts without any manual intervention, directly addressing the vulnerability of traditional methods. So the third pillar is the web-based admin dashboard, built with React.js. It provides guide high-quality face capture during enrollment. ensuring that the data going into the system is clean and consistent, solving the inconsistent enrollment problem. Administration can create, update, or revoke user access from single portal, and every event is logged, tracking who accessed the machine and when, creating a full compliance and audit trail. So this is the module diagram for my system. So the system is organized into three core modules. Firstly is the authentication module, the HI unit. It handles real-time face detection, depth-based liveness verification, facial embedding, and matching using cousin similarity, and local logging of all authentication results. Secondly, the admin module, which are the web dashboard. It manages user enrollment, face capture, profile updates, access verification, and audit log visualization. And lastly, the IoT module, which handles the hardware control. It's handle the motor actuation, GPIO communication, identity synchronization, and immediate access enforcement when authorization is granted or denied. So let me now walk you through the end-to-end system flow. Phase one is registration. An administrator captures a user's face through the admin web interface. The JSON processes the image to generate an AI feature vector, which is then stored as a reference template in the SQLite database. Phase 2 is the real-time authentication. When a user approaches the machine, the internal sense camera captures both RGB and depth data. The depth data is immediately analyzed for liveness. If a spoof is detected, the system is stopped right there. If the face is real, the RGB data is processed by the TensorRT engine running the CNN model to generate a live feature vector. This vector is then compared against the stored template using cousin similarity. If there's a match, access is granted. The system triggers action 1, the machine missing process will begin. Action 2, the motor unlocks the door for medicine retrieval. If there is no match, access is denied and everything is locked. The system delivers four key benefits: spoof-proof security. The 3D depth sensing eliminates the risk of stolen ID cards or shared pins entirely. Secondly, uncompromised privacy. Biometric data is processed and stored locally on device with no cloud exposure. And thirdly, instant and efficient. The TensorRT optimization delivers real-time processing at 28 to 32 frames per second, ensuring zero operational delay. And finally, immutable accountability. Every access event is automatically logged in SQLite, creating a forensic audit trail that cannot be altered. So for the entrepreneurship opportunities, the system also has strong commercial potential. The primary target market is the health sector, automated pharmacies and smart hospital, and pharmaceutical compounding clean rooms that are looking to replace outdated ID or PIN-based access control. Then our business model would be B2B licensing. The dilution, software stack to medical equipment manufacturers who can integrate it directly into their next generation automated mixing machines. On the cost side, running highly optimized custom model on affordable edge hardware like the Jetson Orinano keeps deployment costs low. And finally, because of the software stack is built on fast API and React, it is highly scalable. It can easily integrate with existing hospital management networks or larger IoT pharmacy ecosystem. More for the system. So let's log in as an admin first. So as an admin, you are the only one that have access to the Face ID management. So Face ID management is where I'll build the security system. So as you can see, this is the dilution security dashboard where we can see real-time status of the machine. We can see the user status. It is locked right now. There's no active operator, and this is where it shows the emergency control if you want to initiate override. And we have the security metrics that show failed authentication, spoofing events, or processing latency. And here we have system performance, which shows the to-do activity. As you can see, 12 successful access grants, system uptime, and response time. So here also we have active alerts where it shows the spoof or unknown person trying to access the machine. And here we can acknowledge anything that happened here. Clear all. And then we have the personnel section. So this is where uh, the authorized personnel are listed. As you can see here, we have two people right here, Danish and Nurul. Their role are nurse and pharmacist. Status dia are active, and last access timestamp. We can easily revoke or grant the access in order if we want to uh, or to decide whether they can use the machine or not. And we can also delete their Face ID from the database here in the action. And then we have the enrollment section. So this is where we capture our Face ID. So first of all, let me demo it to you. Fatih. And we will select our role as a pharmacist. We will start scan. Scan. Show Alma's face. And okay. And you can see my name is already appear there. So this is the incident tab. As you can see here, this is where the system show us if there is a spoofing attack is happening at the machine, and authentication failure if there's unrecognized person. You can see that if there is an attempt to use the machine by using photo or showing your face on the phone, it will detect it as a spoof and send you a notification via Gmail and this dashboard incident. You can see here, this is our model: face detection, face recognition, and mask detection. And this is the live feed if you want to see what is currently going on at the machine if you are far away from the machine. And this is the audit logs where you can see authorized personnel that using the machine or unknown person that trying to access the machine. So here we can see here detailed access reports and user activity tracking for complete regulatory compliance. So here we can see the time when they access the machine. You state the time, date, and date. So you can also download the data in CSV file, and you can see it here. Open file, and here is it. You can see who or whom trying to access the machine. Let's see. And then last one, we have setting. This is where we adjust the recognition threshold. So the higher you adjust it, the stricter it become. So the effective way to set it is at 85% threshold. And we have the maintenance override. So let's say we want to somehow the machine is going under through maintenance, we can override it so we can access the machine without having to go through the face recognition and face detection. The system as a pharmacist. So as a pharmacist, you are the only one that have access to initiate the medicine mixing process by going to robot execution and monitoring. So right here for face ID verification, you show your face to the camera, and it will let you access the robot execution and monitoring. And here you will execute the job card which hold the prescription for the medicine mixing process. Let's say if I want to fool the machine by using a spoof method like showing my photo on the screen. So let me demo it to you right now. In the robot execution, you can see it won't let me go past here. And that show that using a spoof method like photo or show your face using a phone or a tablet, it will let you pass the Face ID verification. So this can protect the security of the system. So no unauthorized user can use it. Finally, our medicine mixing process will take place and we will receive our medicine. That's all from me. Thank you for your attention.